in Pharmaceuticals in association with Higher Secondary Principals Forum.
Inverse trigonometric functions. It is a second chapter in the NCERT book. And in 11th standard you have done trigonometric functions. So it is a continuation of that chapter. So you should know very well trigonometric formulae, trigonometric ratios of different angles, and the signs of trigonometric functions in different quadrants. A, S, T, C, all sine, tangent and cosine. This you should know very well. And in the first chapter, you have done inverse of a function. Inverse of a function. So here to start, I explain what is inverse of a function. We recall the definition of inverse of a function. A function f from a to b is invertible. That means it has an inverse if and only if f is bijective. Bijective means injective and surjective, or 1, 1 and onto. Now, inverse of a function f is denoted by f raised to the power minus 1, but it is nothing to do with 1 upon 5 f. Now, if f is a function from a to b, then f inverse is a function from b to a, such that f composition f inverse is identity function on b and f composition f is identity function on a. Now, what do you mean by identity function? Here, f composition f inverse of x is equal to x for every x in B. Therefore, it is called identity function on B. Every element of B image is an element itself. Image of every element of B is an element itself. And similarly, f inverse composition f of x is equal to x for every x belongs to A. Therefore, it is an identity function on A, IA. Let us see what is inverse of sine function. Inverse of sine function, here sine function from R to R, it is not injective and it is not surjective. I explain it using an example. Here sine 0 is equal to sine pi and you know value is 0, but 0 not equal to pi. That means two distinct elements 0 and pi have same image. Therefore, the function is not 1, 1 function, it is not injective function. Similarly, there is no x value in R such that sin x is equal to 2. Why? Because you know that sin x is always a value between minus 1 and 1, including minus 1 and 1. So, what does it show? 2 does not have pre-image. Therefore, the function is not surjective or not onto function. And look at the graph of sine function. You know it is like a wave passing through origin. When you take x-axis, what is the y coordinate on x-axis? 0. So, here y coordinate is 0, here also y coordinate is 0. That means what is this point? It is 0 comma 0. F of 0, sine of 0 is 0. That is why it is passing through origin. Similarly, this point you can see 3 here. 3, just little more than 3 means you know that pi value is 3.14. So, here this point is pi. This is pi comma 0. Sine pi is 0. Sine 2 pi is 0. Sine minus pi is 0. Sine minus 2 pi is 0. For many values it is 0. So, it is a many to 1 function. Many to 1 function. Similarly, if you draw a line parallel to x-axis passing through 1 comma 0, it is touching the graph at many points. So, it shows the function is many to 1 function, not injective function. And similarly, if you draw a line parallel to x-axis passing through 0 comma 2, it does not touch the graph. That means 2 does not have pre-image. Therefore, it is not injective function, not surjective function, not onto function. Therefore, this function is not injective or not surjective. Now, so to define inverse of sine function, we have to take proper subsets of set of real numbers as domain and codomain, so that the function is injective and surjective, 1, 1 and onto. Let us see what are those subsets. Look at this function, sine function, from closed interval minus pi by 2 to pi by 2 to closed interval minus 1 to 1 is bijective. What do you mean by closed interval minus pi by 2 to pi by 2? Last year you have done it in the chapter sets. It is set of all the real numbers lying between minus pi by 2 to pi by 2, including minus pi by 2 and pi by 2. Similarly, this set is set of all the real numbers lying between minus 1 and 1, including minus 1 and 1. So, this function is bijective. Let us see what is the graph of this function. This is the graph of this function. Here you can see x value. It is x value approximately 1.57, approximately pi is 3.14 divided by 2, approximately 5.57, not exact. So, this is pi by 2 and here you can minus pi by 2, here you can see plus pi by 2 and the y value is varying between minus 1 and 1. This is the graph of sine function which is bijective. Here if you draw any line parallel to x-axis between 1 and minus 1, it intersects the graph at only one point. Any line between 1 and minus 1 parallel to x-axis intersects the graph at only one point. That means every y between minus 1 and 1 has one pre-image and only one pre-image. So, it shows it is both injective and surjective. And the previous, it is a part of the previous graph. I will show you the previous graph. It is here from minus pi by 2 to plus pi by 2, this graph. This graph, it is a portion of the previous graph. Okay. Now, we can define inverse of sine function. Let us see what is the definition of inverse of sine function. So, if f is a function from a to b, f inverse is function from b to a. Similarly, sine inverse is a function from closed interval minus 1 to 1 to minus closed interval minus pi by 2 to pi by 2, such that sine inverse of x is equal to y if sin y is equal to x, where x is between minus 1 and 1 including minus 1 and 1, and minus pi by 2 less than or equal to y less than or equal to pi by 2 means y is in this set. This is the inverse of sine function. Let us see what is the graph of this function. This is a graph of the sine inverse function. Here y value is varying between minus 1 and 1, x value is varying between minus 1 and 1, and y value is varying between minus pi by 2 and pi by 2. X value is varying between minus 1 and 1 in this interval, y value minus pi by 2 to plus pi by 2. So, this function is the inverse of sine function. Now, here you can write the domain minus 1 to 1 as union of two sets, two intervals, minus 1 to 0, 0 to 1. You are breaking into two intervals. Here, minus 1 to 0, when you take, when x value is between minus 1 and 0, the y value is between minus pi by 2 to 0. When x is between minus 1 and 0, y is between minus pi by 2 and 0. Similarly, when x is between 0 and 1, y value is between, x is between 0 and 1, y value is between 0 and plus pi by 2. When x is in this set, y is in this set. When x is in this set, y is in this set. So, now look at sine inverse of negative value. Sine inverse of negative value is an angle between minus pi by 2 and 0, means it is an angle in the fourth quadrant. We have done last year angles in first quadrant, second quadrant, fourth quadrant. How we are done? Pi by 2 to 0 first quadrant, 0 to pi by 2 first quadrant, and pi by 2 to pi second quadrant, pi to 3 pi by 2 fourth quadrant, 3 pi by 2 to 0, pi to 3 pi by 2 third quadrant, 3 pi by 2 to 0 fourth quadrant, 0 to pi by 2 first quadrant, pi by 2 to pi second quadrant, pi to 3 pi by 2 third quadrant, 3 pi by 2 to 0 fourth quadrant. But here what we have is minus pi by 2 to 0. How negative angles are formed? Negative angles are formed by rotating x-axis in the clockwise direction. So, negative 30 degrees, negative 30 degrees. This angle is negative 30 degrees. Okay. Now, negative pi by 2. So, negative pi by 2 is, negative pi by 2 is the position of negative pi by 2 and 3 pi by 2, 270 degrees are same. So, 0 to negative pi by 2 or negative pi by 2 to 0 is also fourth quadrant, and 0 to pi by 2 is first quadrant. Therefore, sine inverse of a negative value is an angle in the fourth quadrant. Fourth quadrant means not between 3 pi by 2 and 2 pi, it is between negative pi by 2 to 0. Sine inverse of positive value is an angle in the first quadrant which is between 0 and pi by 2. Between 0 and pi by 2. From the graph also you are getting the same 0 to 1, 0 to pi by 2, 0 to minus 1, 0 to negative pi by 2. That is sine function. So, here I am giving some examples. Sine inverse of half. Here half is in the interval 0 to 1. Sine inverse of half is equal to pi by 6. Why? Because sine pi by 6 is equal to half. Not only that, pi by 6 is between minus pi by 2 and pi by 2. It is in the interval. It is coming in the interval minus pi by 2 and pi by 2. It is in the interval 0 to pi by 2. Okay. Similarly, sine inverse of negative half is negative pi by 6, because sine of negative pi by 6, you know sine of minus theta is minus sine theta. So, sine of negative pi by 6 is negative sine pi by 6, which is negative half, and not only that, minus pi by 6 is an angle between minus pi by 2 and plus pi by 2. It is coming between minus pi by 2 and 0. Therefore, sine inverse of minus half is minus pi by 6. It is very easy to find out sine inverse of a negative value. Okay. Now, let me go to the next function, which is cosine function. Let us see what are the domain and codomain of cosine function, so that the function is bijective. Inverse of cosine function. Cosine function, like sine function, when you take r to r, it is not injective or surjective. So, we have to take closed interval 0 to pi as domain and closed interval minus 1 to 1 as codomain to make it bijective. Let us see what is a graph of this function. Its graph is, you know the graph of sine cos function, it is also like a wave. So, this is a part of the wave from 0 to, you can see just above 3 means pi, 0 to pi, 3.14 is approximate value of pi. So, it is just above pi, 0 to pi, and cos x value is, x value 0 to pi, cos x value is minus 1 to 1. So, this function is a bijective function. So, in this case we can define its inverse. The inverse of the function is from closed interval minus 1 to 1 to closed interval 0 to pi, such that cos inverse of x is y if cos y is equal to x, where x is a value between minus 1 and 1, y is a value between 0 and pi, including 0 and pi. So, that means x belongs to this set, y belongs to this set. This is the inverse of cosine function. Let us see what is the graph of cosine function. Cosine function graph is like this. Here y is varying between minus 1 and 1, here x is varying between minus 1 and 1. Here y is varying between, x is varying between 0 to pi, here y is varying between 0 to pi. Okay. So, this is the inverse of this function, reverse relation, inverse. Okay. So, let us see the breaking of the intervals. Minus 1 to 1, we can write as union of these two intervals, minus 1 to 0 and 0 to 1, like sine function. But here it is not like sine function, here codomain or range, since it is bijective I can call it range. range of the function is different, 0 to pi by 2 to pi by 2 to pi. We break it like this, 0 to pi by 2, pi by 2 to pi. 0 to pi by 2. You know 0 to pi by 2 is an angle in the first quadrant, pi by 2 to pi is an angle in the second quadrant, 0 to pi by 2. Now, when you take cos inverse of value between 0 and 1, cos inverse of a value between 0 and 1, you can see its y value lies between 0 and pi by 2. This is pi by 2, approximately 1.57, 0 to pi by 2. So, if it is value between 0 and 1, cos inverse is lying here like this. Similarly, if x is a value between minus 1 and 0, cos inverse of x is lying between pi by 2 to pi, pi by 2 to pi. If it is between minus 1 and 0, it is lying in this second quadrant. Cos inverse of positive value lying in first quadrant like sine inverse. Cos inverse of negative value lie in the second quadrant, not like sine inverse of x. It is in the second quadrant from pi by 2 to pi. Okay, now let us go to the next trigonometric function, sine, cosine, then tangent function or tan function. Inverse of tangent function. Tangent function from open interval minus pi by 2 to pi by 2 to r is bijective. What is open interval? It is also set of all the real numbers between minus pi by 2 and pi by 2, but excluding minus pi by 2 and pi by 2. And codomain is R. Now the function is bijective. Let us see what is the graph of this function. The graph of this function is like this. It is not ending here or ending here, it is continuing because the codomain or range is set of real numbers. So it is not the end. It is going close to the line x is equal to pi by 2, and here this side it is going close to the line x is equal to minus pi by 2. That is a graph of tan function, but tan pi by 2 does not exist, tan minus pi by 2 does not exist. That is why minus pi by 2 and pi by 2 are not included in the domain. Okay. Now let us see what is the inverse of this function. Since this is domain, this is range, inverse, the range domain is R, range is minus pi by 2 to pi by 2, such that tan inverse of x is equal to y if tan y is equal to x. And where x is a real number, any real number it can be, y is between minus pi by 2 and pi by 2 excluding minus pi by 2 and pi by 2. That means y belongs to this set. Is the inverse of tangent function or tan function. Now let us see what is a graph of inverse of tan function. Inverse of tan function. It is also not an x value, you can take any value, tan inverse of any value is defined. And it is between, tan inverse of any value is lying between minus pi by 2 to plus pi by 2. Can take any real value, not like sine inverse or cos inverse. Let us see two examples. Here also, here the domain range is minus pi by 2 to pi by 2. It is like sine function, we can break it from minus pi by 2 to 0 and 0 to pi by 2. Only minus pi by 2 is not included, pi by 2 is not included. All values between minus pi by 2 to 0. So, here fourth quadrant tan is negative. ASTC only cos is positive and first quadrant tan is positive. So, tan inverse of a negative value like a sine function, sine inverse, it is an angle between minus pi by 2 and 0. Tan inverse of positive value is between 0 and pi by 2. Here also when you look at this, tan inverse of negative values between 0 and negative pi by 2 and 0, tan inverse of positive value between 0 and pi by 2. First quadrant positive, fourth quadrant negative. Okay, let us see two examples. Here, tan inverse of positive root 3 is pi by 3, 60 degrees. Tan 60 is root 3, you know that. Tan pi by 3 is root 3. But don't write in degrees, you should write it in radians. Because pi by 3 lies between minus pi by 2 and plus pi by 2. And tan pi by 3 is root 3. And tan inverse of negative value, negative pi by 4. Because tan of negative pi by 4 is 1. And not only that, negative pi by 4 lies between minus pi by 2 and pi by 2. So, two examples, one positive, one negative. Now, let us go to the next inverse trigonometric function, which is inverse of cosec function, which is reciprocal of sine function, and cosec function is bijective if the domain is closed interval minus pi by 2 to pi by 2 minus 0. From that you have to remove 0. 0 should not be included because cosec of 0 is not defined. Sin 0 is 0, cosec 0 is 1 by 0 not defined. Therefore, 0 should be removed from the domain. So, otherwise the domain is same as domain of sine function except 0. And range is different. Range is R minus open interval minus 1, 1. What do you mean by that? R minus open interval minus 1, 1. From set of real numbers, remove that interval minus 1, 1. That means it can be any real number greater than 1, greater than or equal to 1. We are not removing 1 because it is open. Only open interval we are removing. So, x can be greater than or equal to 1. This value, a number in this can be greater than or equal to 1, and it can be less than or equal to minus 1. That is the set. Set of all the real numbers greater than or equal to 1 or less than or equal to minus 1. This function is bijective. Okay, and now let us see what is inverse. Therefore, the function cosec inverse is function from R minus this. This is codomain here, here domain. So, they become range. This become range because it is bijective function. So, this is the domain R minus open interval minus 1, 1, and range is open closed interval minus pi by 2 to pi by 2 minus 0 is cosec inverse of y if cosec y is x, where modulus of x is greater than 1. I did not write like this. The meaning is same. Modulus of x is greater than 1 means x can be any number greater than or equal to 1, or x can be any number less than or equal to is there, less than or equal to minus 1. Similarly, y is minus pi by 2 less than or equal to y less than or equal to pi by 2. Then y belongs to this set and y not equal to 0. This function, this is the inverse of cosecant function. Let me show you the graph of cosecant function. This is graph of cosecant function. I did not show the graph of cosec function, cosecant function. Cosecant function graph is, it is a graph of inverse of cosec function, inverse of cosec function, graph of inverse of cosec function. It is a function here, x value. X value you can see from 1 to infinity, minus 1 to minus infinity. It is not ending here. And y value, x value is in this. Y value is between minus pi by 2 to pi by 2. And it is not touching 0. So, 0 is removed. It can be any value between minus pi by 2 and pi by 2. This graph is not touching y equal to 0. This graph also not touching y equal to 0. It is going close to the line y equal to 0. It never touches the line y equal to 0. Therefore, y not equal to 0. Okay. Now, let us take two values. So, it is like sine inverse function, cosec inverse function is like sine inverse function, cosec inverse of root 2. Cosec inverse of root 2 is pi by 4 because cosec pi by 4 is root 2 and pi by 4 belongs to the set. Open closed interval minus pi by 2 to pi by 2 minus 0. And cosec inverse of minus root 2 like sine inverse function, it is an angle between minus pi by 2 and 0. Therefore, it is cosec minus pi by 4 minus root 2 and minus pi by 4 is in the range of the function. Therefore, cosec inverse of minus root 2 is minus pi by 4. Now, let us go through inverse of second function. Second function is in reciprocal of cos function. So, the domain of second function 0 to pi minus pi by 2. Cos function also domain was 0 to pi. But the only difference here pi by 2 is not included because sec of pi by 2 is not defined. And codomain is r minus open interval minus 1 1 like cosec function. It is bijective. Okay. And here therefore, we can define the inverse of second function. Second inverse is a function from r minus open interval minus 1 to 1 to closed interval 0 to pi minus pi by 2. And sec inverse of x is y if sec y equal to x, where modulus of x is greater than or equal to 1. That means x is greater than or equal to 1 or x is less than or equal to minus 1. It belongs to this set. 0 less than or equal to y, less than or equal to pi, y not equal to pi by 2. That means y belongs to this set. Is the inverse of second function. Let us see what is a graph of second function. This is a graph of second function. It is, you cannot see values between minus 1 and plus 1. And you can see sec inverse of 1 is 0. Similarly, sec inverse of minus 1 is pi. Sec inverse of 1 is 0. Sec inverse of minus 1 is pi. And here, so that is a graph of second function, and like a cos inverse, sec inverse of negative value is in between minus pi by 2 and pi, and sec inverse of positive value between 0 and pi by 2. So, let me give you examples. Sec inverse of positive value 2 by root 3 is pi by 6 because sec pi by 6 is 2 by root 3. Not only that, pi by 6 is an angle between 0 and pi minus pi by 2. Sec inverse of minus root 2 is 3 pi by 4 because sec of 3 pi by 4 is minus root 2. 3 pi by 4 is an angle in the second quadrant. It is pi minus pi by 4. 3 pi by 4. It is an angle in the second quadrant and 3 pi by 4 belongs to closed interval 0 to pi minus pi by 2. Therefore, sec inverse of minus root 2 is 3 pi by 4. Now, let us see the next inverse function, inverse of cotangent function. Cotangent or cot function, which is reciprocal of tan function. But the domain of cot function we take open interval 0 to pi. Tan function domain was minus open interval minus pi by 2 to pi by 2. Cot is 0 to open interval 0 to pi. 0 is not included, pi is not included. And codomain or range is same as set of real numbers. So, it is bijective. So, you can define the inverse. Therefore, the function cot inverse is a function from R to open interval 0 to pi such that cot inverse of x is y. If cot x is equal to y, where x belongs to R, y is between 0 and pi, is the inverse of cotangent function or cot function. So, the graph of the inverse function is like this. It never touches y equal to 0. That never touches y equal to 0. It cannot be 0. This is pi, just above 3 pi. It is going very close to the line y equal to pi, but never touches the line y is equal to pi. It is between pi and y equal to pi and y is equal to 0, which is x axis. And here inverse, now cot inverse of positive values. Cot inverse of positive values are between 0 and pi by 2. Cot inverse of negative values are between pi by 2 and pi. Like cos inverse it is. It is like cos inverse in the second quadrant. Cot inverse of positive value in the first quadrant, cot inverse of negative value in the second quadrant like cos inverse. Second quadrant like cos inverse, not like tan inverse. So, here example, cot inverse of 1 is pi by 4, cot of pi by 4 is 1 and pi by 4 is between 0 and pi. Cot inverse of minus root 3 is 5 pi by 6. 5 pi by 6 means pi minus pi by 6, 5 pi by 6. It is an angle in the second quadrant. It is minus root 3 and it is between 0 and pi, 5 pi by 6, approximately 5, exactly it is 5 into 30, 150 degrees, between 0 and 180 degrees. It is an angle in the second quadrant. So, cot inverse is not like tan inverse, cot inverse of negative value, not like tan inverse of negative value. Okay, these are the inverse functions. Now, it is very difficult to remember all the domain and codomain of range of inverse functions. So, I prepared a table to remember domain and range of different inverse functions. So, if you learn this, it is easy for you to find out inverse values. Sine inverse of x, domain minus 1 to 1 to closed interval minus pi by 2 to plus pi by 2. Cos inverse of x, closed interval minus 1 to 1, they are same, domains are same. but ranges are different 0 to pi. Here it is fourth quadrant and second quadrant, minus pi by 2 to 0, fourth quadrant, 0 to pi by 2, first quadrant, and cos inverse 0 to pi. So, 0 to pi by 2, first quadrant, and pi by 2 to pi, second quadrant. Tan inverse domain is our ranges like sine inverse, but excluding minus pi by 2 and pi by 2. So, it is fourth quadrant and first quadrant. Cosec inverse domain is from set of real numbers, remove open interval minus 1 1, and its ranges like sine inverse excluding 0. And sec inverse domain is like cosec inverse r minus, remove open interval minus 1 1, and its range is 0 to pi like cos inverse excluding pi by 2. But cot inverse of x domain is set of real numbers, it is like tan inverse, but the range is only 0 to pi, it is first quadrant and second quadrant. So, the problem cot inverse of negative value will be angle in the second quadrant, but tan inverse of negative value will be angle in the fourth quadrant between minus pi by 2 and 0. All positive values in the first quadrant, it is very easy to find out. If you know the trigonometric ratios of different angles, tan inverse of positive value you can easily find out. Now, I give some example. Sine inverse of minus 1. What is sine inverse of minus 1? Sine of which angle is minus 1? Sine of which angle is minus 1? Sine of minus pi by 2. That should be in this. Sine of 3 pi by 2 is also minus 1, but it should be an angle in this. It should be in the range. So, sine of minus pi by 2 is minus 1. Therefore, sine inverse of minus 1 is equal to minus pi by 2. Okay. Now, let us see another example. Cosec inverse of minus 2 by root 3. Cosec inverse of minus 2 by root 3. What is cosec of 2 by root 3? Cosec of 2 by root 3 is, cosec of which angle is 2 by root 3? That is what I am asking. Cosec of which angle is 2 by root 3? Cosec of pi by 3, 60 degree is 2 by root 3. So, cosec of minus 60 degree or minus pi by 3 is minus 2 by root 3. It should be in this angle, in this quadrant. Therefore, the answer is minus pi by 3. Now, but cos of minus 1 by root 2. What is cos inverse of minus 1 by root 2? Cos inverse of minus 1 by root 2. Cos of which angle is plus 1 by root 2? Cos of pi by 4 is plus 1 by root 2. Therefore, but this should be an angle in the second quadrant. Second quadrant, cos inverse, sec inverse, cot inverse. You have to be little careful. It should be angle in the second quadrant. So, it should be pi minus pi by 4. Pi is little less than pi. Pi minus pi by 4. Pi minus pi by 4. So, which is 3 pi by 4. Now, look at another example. Sec inverse of minus 2. It is also should be angle in the second quadrant. Sec of pi by 3 is 2. So, sec of, you have to take corresponding angle in the second quadrant so that sec value is minus 2. So, pi minus pi by 3, 2 pi by 3 is sec inverse of minus 2. Okay, some examples I give. Now let us go through some properties of inverse function. Sine of sine inverse of x. Sine of sine inverse of x is equal to x if x belongs to closed interval minus 1 to 1. It should be between minus 1 and 1, including minus 1 and 1. You will not get sine inverse of 2 because it does not exist. So, what is this interval? This is a domain of sine inverse function. Domain of sine inverse function. Therefore, x should be belongs to the domain of sine inverse function. And here sine inverse of sin x is equal to x. What is x here? X should be in the domain of sine function. X belongs to closed interval minus pi by 2 to pi by 2. It should be in the domain of sine function. Then sine inverse of sin x is x. Similarly, for other trigonometric functions, you can see what is the domain according to that. Cos of cos inverse of x is x, same domain, x belongs to open interval, closed interval minus 1 to 1, but cos inverse of cos x is x if x belongs to 0 to pi. That depends on what is the domain of this function, second function here. Okay. So, that we can write for all the 6 trigonometric functions. And now, but here you may get sometimes angle which does not belong to this. Then how do we find out the value? Let me explain one or two examples. With example I will explain. Sine inverse of sine of 4 pi by 3. Here 4 pi by 3 does not belong to closed interval minus pi by 2 to pi by 2. But still we can find the value. We will see how to find out the value. Here sine inverse of sine of 4 pi by 3, which is sine inverse of sine of pi plus pi by 3. It is an angle in the second quadrant. Pi plus pi by 3, sorry, third quadrant. Pi by 3 is approximately 6, it is 60. So, 4 into 60, 240. So, it is an angle in the third quadrant. So, pi plus pi by 3. So, sine of pi plus pi by 3 is minus root 3 by 2. Therefore, the answer is minus pi by 3. So, if you know, there is no need of doing all this. If you know it is a negative value, so it should be angle in the fourth quadrant between minus pi by 2 and 0. So, you can directly write minus pi by 3. Similarly, cos inverse of cos of 7 pi by 6. 7 pi by 6, 7 into 45, 315 degrees. It is an angle in the fourth quadrant. Cos is positive in the fourth quadrant. So, it is equivalent to cos of pi by 4. Pi by 4 is in the range domain of cos function. Therefore, the final answer is pi by 4. Because 7 pi by 4 is an angle in the fourth quadrant, and fourth quadrant cos is positive. So, it is equivalent to cos of pi by 4. The answer is pi by 4. 7 pi by 4 is in the domain of, is not in the domain of cos function or not in the range of cos inverse function. Therefore, it should come in the range. Therefore, it is we have to take pi by 4. Now, two more examples I will explain. Find the value of sine of cos inverse of 3 by 5. Here, to find sine of cos inverse of 3 by 5. Let us take cos inverse of 3 by 5 equal to theta. Then cos theta equal to 3 by 5. You will get a triangle. Okay, this angle is theta, and you know cos theta is opposite, adjacent upon hypotenuse, adjacent upon hypotenuse. So, let me take opposite as y. By Pythagoras theorem, y is equal to root of y is 5 square minus 3 square, which is 4. Therefore, sin theta is 4 upon y upon 5, which is 4 upon 5. Therefore, theta is sin inverse of 4 by 5. So, from 1 and 2 both are theta, this also theta, this also theta. So, you can write sine of cos inverse of 3 by 5, you can write sine of sin inverse of 4 by 5, which is equal to 4 by 5. One more example, find sec of cot inverse of 7 by 9, 7 by 9. Here without taking triangle you can write, because cos inverse of 7 by 9 is cos A is 7 by 9. If you take triangle like this, you will get the same answer. Sec A is, because you know the relation between cos A and sec A is 9 by 7. Therefore, A is sec inverse of 9 by 7. So, sec of cos inverse of 7 by 9 we can write as sec of sec inverse of 9 by 7, which is equal to 9 by 7. So, we are getting sec of sec inverse of 9 by 7, since it is in the range, we are getting 9 by 7, it is equal to 9 by 7.
Prudent Scholars, powered by Lupin Pharmaceuticals.